Hello everyone, have you ever seen inside a radio? Today, we are going to do just that. Welcome to this second series of Tech Unveil. We are back to give you the backstage pass into our groundbreaking technologies. I am Nga Kim and I will be your host today on this episode where we will unveil the magic behind the most critical elements in building a great 5G network, the Massive MIMO radio system. So let's go meet the real expert and find out. With me today, I have Sibel Tombaz, Head of 5G High Band and Active Antenna System. Welcome back to Tech Unveil, Sibel.
Thank you.
And joining Sibel, Peter Moberg, Head of Massive MIMO Radio Solutions. Fantastic to have you here, Peter.
Thank you.
So, Sibel, what do we need to think about when building a great 5G radio system?
So first, let's define what a great 5G system is. It's a system that will create platform for innovation. It's a system that will shape the industries around us and change and redefine our connectivity needs. And this great 5G system will provide high-quality experience in any time, anywhere, by any application. And this will require high speed and a lot of capacity. And we believe that access to spectrum in the higher frequencies is essential to realize the 5G vision due to the availability of larger bandwidth. But we have few key challenges to solve. First, coverage. We need to overcome the challenges with the coverage in the higher frequencies, because as we go to the higher frequencies, the range goes down. The second is spectral efficiency. We need to maximize the spectral efficiency in order to optimize the investment from the acquiring more spectrum. And while we are doing all these things, we need to ensure that we need to minimize size, weight, and power consumption of the radios so service providers can have faster and more cost-efficient rollout. And our answers to all these problems is Ericsson Massive MIMO, which is integrated across hardware and software, which is powered by Ericsson Silicon, and it also provides an industry-leading combination of size, weight, performance, and energy efficiency.
That's a lot. Let's break it down. Why is it so important to use spectrum efficiently?
There are multiple reasons why we need to use the spectrum efficiently. First of all, access to spectrum gives you bandwidth, and more bandwidth gives you higher speed and more capacity. And considering the increasing traffic in the mobile networks and high demand for 5G connectivity by consumers and industries, mobile operators need to access the spectrum to be able to cater this demand. Spectrum is also a scarce resource and thus expensive. In January this year, FCC actually opened an auction in C-band spectrum in US, and the total price of a 280 megahertz of spectrum landed beyond $80 billion. So that's why it's extremely important that we maximize spectral efficiency by pushing the boundaries of technology.
And if I could add to that, Sibel, you have this coverage challenge with the high frequencies. And one way would, of course, be to just add new sites. But that is typically not economically feasible, or it takes too long time and it's cumbersome. So what you really want to do is to reuse the existing sites. And then you have to think about two factors. One is to keep the size small, the weight low, and the power consumption low. And then you have the fundamental challenge of physics to go to higher frequencies. But there we have some innovative solution in our Massive MIMO radio to help physics on the way.
What a teaser, Peter. Clever physics tricks. Can't wait to learn more. So, Peter, can you explain how Ericsson high-performing Massive MIMO can make it a reality?
Sure. Let's start with the higher frequency, lower reach challenge. So one way to combat that, we can look here. This is an Air 6449, and it has 192 antenna elements in the radio. And an increase in the number of antennas really increases also the coverage and the gain, both when transmitting and receiver to the users. But the real challenge here is to use all these antenna elements in a smart way with algorithms and direct the beams to specific 5G users.
Yes, and that's exactly what we do. We create beams by adding signals from multiple antennas coherently based on the channel information. And with that, we can boost the signal exactly where we want to, towards the user we want to have the communication, And at the same time, we reduce the interference to all other directions where we don't want the energy to go or come from. And that is the essence of our Ericsson Massive MIMO radios.
That is super clever. But how does it work in practice? You know, devices moving around the whole time.
That's correct. And that's actually the biggest challenge. In fact, the radio environment change in sub-millisecond level, and as the devices move around. And adding to the complexity, we have hundreds or thousands of devices in the same cell. And here, the key to success is the real-time knowledge of the channel. Because that's the only way you can know how the channel looks like in real time, and you can adjust the beams towards where you want to boost the signal, and at the same time minimize the interference to all the other directions where we don't want to spread the energy. And that is what we do in our Ericsson Massive MIMO radios. With our unique capability of instantly estimating the channel information at the radio, by doing millions of calculations per second, we can reshape the beams instantly, and we can ensure that all 5G users in the cell gets the best performance.
Wow, that is really amazing. Can you explain what goes into the design of those Massive MIMO to make that happen?
Yeah, so you have this wide bandwidth and all these beamforming algorithms, and that drives a lot of processing need. So we're talking at least a factor of 20 times compared to a normal 4G system. So that's the challenge you need to handle at processing. At the same time, as we talked about, you cannot compromise on size and weight increase. So that's the challenge.
That sounds like a paradox to me. You want it to be more powerful at the same time maintaining size and lower power consumption. How does that work?
Yes, exactly. So that's really, now we come to the uniqueness and secret sauce of the Ericsson solution. And it's really three components. First is Ericsson Silicon, being the enabler of our superior architecture and innovative beamforming solution. So if we start with Ericsson Silicon, that is really we talked about this processing need, and that is really the solution to combat that processing need, and at the same time keep size, weight, and power consumption as low as possible. And that in itself is also the enabler for our unique and superior architecture, where we are able to move more processing to the radio and leverage this instant information. So there we have a unique architecture. And based on that architecture, we can also do a lot of innovative beamforming solutions. Maybe you can talk more about that, Sibel.
Yes. So the third component of our Massive MIMO solutions is our innovative beamforming algorithms. Thanks to our industry-leading Massive MIMO radios, as Peter mentioned, with our superior architecture and powered by Ericsson Silicon, now we have access to all this data about how the channel looks like in real time. So which means that we exactly know where the user is and how the conditions are in terms of data and the interfering channels. And all this data and processing power makes innovation easy. So what we do is we create algorithms on top of this data with our large expertise in the area, and we bring the best coverage extension solutions for Massive MIMO. With our uplink booster, we get 10 dB coverage gain. We also enable the best spectral efficiency with our multi-user MIMO algorithms, and which enables us to schedule the two users or more users in the same time and frequency domain without creating any interference between them, even though when they are sitting next to each other. And lastly, our Massive MIMO radios create platform for innovation, because now we have the access to data and we have a large processing capability, and that enables us to unlock the full potential of AI-based signal processing at the radio, which means that with our Ericsson Massive MIMO radios, we are bringing the AI at the extreme edge. This enables Ericsson Massive MIMO to provide the best coverage and capacity that will remain unmatched.
Thank you, Sibel and Peter. I learned so much today. Going forward, on the next episode of Tech Unveil, we will talk about another very important topic of building a high-performing 5G network, the RAN security capabilities. Everyone, make sure you don't miss out on the next episode by setting a reminder on ericsson.com/techunveil, one word. It has been a great pleasure to have you here today. Thank you for watching, and I see you in the next one. Goodbye.